towards ENCODE. So the first comment that Grayson made was over 90% of endogenous retroviral-like sequences. That includes the pieces of ERVs, like LTRs, solo LTRs, and your full ERV sequences that comprise LTR on either side, GAG, POL, and ENV genes within the middle. So, Grayson, can you provide a citation that says or indicates that over 90% of these are non-functional junk?
No, it's 1 a.m. That's not what I claimed. I claimed 0.1% of ERVs have been demonstrated to have a known function. You're flipping my words around and asking for a citation when I'm in a live stream at 1 a.m, 1:30 almost.
So here's the problem with evolutionists is they make a lot of claims.
Yeah.
They make a lot of assertions, but they can't back those up.
Yeah,
and
your
so
little
Grayson,
rhetorical gotcha sure is cute, Donnie. You can look up all this information and you know that I'm right on this. You know, because you've done the research into what ERVs are functional, and you know,
but you're not
and I have sent you
this.
the math on this before. I have literally sent you the breakdown of the math, calculating these numbers exactly to 0.1%. And I've broken this math down for you, and I have sent you the paper before. So to come on here and ask for the paper when I've already provided it to you months ago is a little fishy, a little sus.
Okay, so we're going to do equal time here, no interrupting. So never have you demonstrated that only 0.1%.
Go through our messages.
Again, I'm trying to finish my thoughts here. You've never provided a citation. I've seen you over and over again in streams, in debates, make this claim, this assertion, that only 0.1% of endogenous retroviral-like sequences are functional. I want to see a citation. I want to see not just an assertion or a claim. I want to see this demonstrated, because I could go through paper after paper after paper talking about widespread functionality in endogenous retroviral-like sequences. And so
you can't.
This claim that you're saying, it's made up. It's not real. It's your philosophy. It's your evolutionary philosophy.
The study on this, and I've sent you the mathematics of calculating the 0.1%, which is actually less than that. I'm being generous here, but I've literally sent you all of this information before months ago.
You've never demonstrated
right here. I'm pulling it up in our
0.1
previous messages, dude. I'm literally pulling it up right now. The paper uses observations of total transcription output to calculate that 0.145% of ERVs exhibit transcriptional potential. Okay, I have the paper right here. I'm going to resend it to you because I sent it to you on November 28th. Okay, you have the paper. It's in your DMs, dude.
Okay, share my screen.
Comprehensive genomic analysis reveals dynamic evolution of. Oh, hold on. I just lost it.
Share my screen, praise. Okay.
Yeah, comprehensive genomic analysis reveals dynamic evolution of endogenous retroviruses that code for retroviral-like proteins.
Okay, so here on the screen,
we observations of the total transcriptional output to calculate that 0.145% of ERVs exhibit any kind of transcriptional potential at all, like that can even be possible candidates for having functions. Okay, that's not even talking about the actual ones that we've demonstrated to have function. That's talking about the total potential that can even potentially have a function after transcription. Okay, I have sent you this literally months ago.
Okay, what's the date on that technical paper? And
November 28th, 2022 is when I sent the message.
Okay, so you sent the message in 2022. I'm talking about the paper itself that excerpt comes from.
September 2020.
September 2020. Okay, and is it cut? So, for example, I'm screen sharing here, and it talks. So you're saying all of these functions where it talks about cell differentiation up on the screen, regulation of gene expression, embryological development, acting as antiviral protectors. You're saying that paper is arguing that all of that comprises just 0.1% of these
less than that even.
Endogenous retroviral-like sequences.
Yes, less than that even. Yes, correct. And you have the paper now. Twice I've sent it to you. I can read the paper right here. Look, the fraction of ERVs possessing open reading frames, which is necessary for transcription. If you don't have an open reading frame, it doesn't get transcribed. The fraction of ERVs that even possess an open reading frame is only 0.15% total out of all ERVs.
Okay, so these open reading frames, is this talking about solo components of your endogenous retroviruses, or is this talking about your whole endogenous retrovirus? Okay, so like what about
the whole or any part? If they involve an open reading frame, meaning a start and a stop codon, right? So if any portion of the ERV contains a start and a stop codon, that's an open reading frame.
No, see, the problem is your solo LTRs, long terminal repeats, your solo components of retroviral-like sequences, that is what comprises your largest portion of endogenous retroviruses.
Mm-hmm.
And those are shown to be functional in gene regulation, gene expression. They are shown to be functional in determining cell types. So it's not just your complete endogenous retroviruses. It's also your solo endogenous retroviral components, you can say.
So they have function that's independent of them being transcribed.
Well, if you're talking about just solo LTRs, again, these represent functional stretches of DNA. If you're talking about your full endogenous retroviral sequences that comprise your LTRs, your GAG, your POL, and your ENV genes, then those function in other ways, such as...
I just want to be clear here that, again, you are talking about a very small fraction of LTRs, and you are trying to generalize them to say all TRs are functional. But the amount of LTRs that we actually do have a function for is a very, very, very small fraction of the total amounts of LTRs. And you're trying to generalize and say that because we found a tiny little portion that has function, that means that all of them have function. And that is faulty reasoning.
I would argue that it's not faulty reasoning. I would also contest the evolutionist claim that says, well, it's just a few that are functional. Firstly, we've tested very little of the genome. Secondly, many of these retroviral-like sequences, including your complete endogenous retroviral units, are actually only functional under very certain circumstances. So, for example, there's a specific class of endogenous retrovirus that is only functional and active in very specific stages of embryological development. And so when they're done doing their
faith that there are some kind of circumstances that we don't know about that will show that functionality from all of these other sequences. You just have faith that there are special circumstances that will demonstrate that it's all really functional.
No, it's based on empirical evidence that we know endogenous retroviruses are many non-coding sections of the genome are only functional under very specific circumstances.
Yeah, what fraction though? Very small fraction, right?
See, the problem with the evolutionists is they have a very unsophisticated view of the 4-dimensional genetic code.
No, I don't. So, the 4D nucleosome project, Grayson, I'm very aware of.
Grayson, I get that you're excited tonight. It's late. I'm not in the mood for over talking each other, but I've noticed that many of the starts of your sentences are starting in the middle of mine. So let me finish my thought, and you'll be able to tell the audience and the world why you disagree with me. Okay?
Exactly, man. Come on.
Okay. You know I get grumpy at late night streams.
Well, I've seen you grumpy at all times of the day, so maybe you need to get on a better sleeping schedule. That's always going to be your excuse.
Eat a popsicle. I'm just kidding.
I'm normally pretty good-natured.
Okay, so the vast number of possibilities in terms of functional roles in these developmental windows is massive. We've only just begun to understand the embryological development and all of these developmental stages and everything that takes place during these stages, not to mention all of the genetic units that are functional, but then they're turned off, they're silenced. And so, yes, to the evolutionist, if there's no activity associated with these genetic units outside of the developmental stages, they are going to conclude that what we're looking at here is basically non-functional units of DNA, when that's not actually the case. Here, I would contest the claim from that paper, because there's paper after paper just like this. This is not from an intelligent design website or anything like that. And yet it reads as if it were. So notice this on screen. Far from being junk DNA, the pervasive retrotransposons that populate the genome have a powerful capacity to influence genes and chromatin. A new study demonstrates how the transcription of one such element, this is talking about a human-specific endogenous retrovirus, can modify the higher order 3D structure of chromatin during early primate development. And so I would say that the trajectory strongly favors our position, but all we would need is a couple examples of these types of sophisticated functional roles to overturn the evolutionary explanation for them, because you guys are the ones with the faith that a harmful exogenous retrovirus like HIV can infect a biological organism, can integrate into the germ cell lines and be passed on and then silenced, and then they gain a functional role. They basically go from a bad virus to a good virus, not only a good virus, but an essential virus.
Nope.
That's what I want to see from you, an explanation for how that's possible.
Sure, I can do that, but are you going to keep talking for 20 minutes? Or, like, I'm trying not to interrupt you, but you bring up a million points and you never stop talking. So
But you asked a question.
Go back to what was just on the screen.
Listen, Mr. Listen, no slapping and running, okay?
I'm not slapping and running. I'm asking you to go back so I can address what you just said. Go back to what was just on the screen here. Okay. Now it says one such element, right? So in total, you've got one out of several million ERVs. Those are not good fractions. And you said, oh, well, if we showed 2 or 3, then that would be enough. No, it wouldn't. That would still be less than 0.1% of all ERVs. Like I'm saying, you are ignoring something called fractions, right? You want to say this, what your claims are appeal to 100%, apply to 100% rather, of ERVs, when all you've demonstrated is that 0.1% of ERVs show any functionality at all. You have not demonstrated that more than 1% of ERVs have any demonstrated function. You just want to point out a couple of examples that constitute a fraction of a percent, and you want to somehow generalize that means all ERVs are functional, which that doesn't work that way.
May I propose a solution to this? Okay.
Oh, no, I want to respond. I'm sitting here patiently. I'm not interrupting. I'm letting Grayson finish his sentence. There's a lot of points on the table that require, at times, unfortunately, lengthy technical responses. So if we look at the citation from the excerpt from this paper here, notice this: far from being junk DNA. And so they are acknowledging that, for the most part, the evolutionary community has assumed that retrotransposons and the various classes of them, including endogenous retroviruses, are junk. But they're saying the pervasive retrotransposons, because yes, the genome comprises a lot of retrotransposons that populate the genome, have. So this is a general statement. It's not just saying, well, just 1 or 2 of them. No, it is saying that the pervasive retrotransposons that populate the genome have, this is one of their roles or assets or components, they have a powerful capacity to influence genes and chromatin. And then it goes into a specific study that then focuses in on one specific element. But it's not just saying, well, that's the only one that's functional, or there's only 2 or 3 that's functional. No, it is pointing out that, yes, there are a lot of retrotransposons in the genome, and a lot of them in general function in X, Y, Z. And for sake of time, I'm not going to list them off.
So if I have a coal mine, okay, and it's 99.99% coal, but I find one tiny little diamond, right? That coal mine now has shown the capacity of producing diamonds. Does that mean 100% of that coal mine is diamonds? No, obviously that's ridiculous. But the coal mine has a capacity to produce diamonds, even if there's only 0.1% diamonds.
May I suggest?
I want to finish this off, Bubblegum. I would argue that it is philosophy for the evolutionists to say that the vast majority of them, 99% of them, more than 99% of these endogenous retroviral-like units are non-functional. in light of these functional roles that we see, and I would also argue and make a prediction based on this paper here in, I think it's 2021, possibly 2021, how endogenous retroviruses protect us from viral infections. So notice this. Long disregarded as junk DNA, so again, pointing that out, endogenous retroviruses have turned out to represent important components of the antiviral immune response. And so what we know, to not go into too much detail, but the fact that your full endogenous retroviruses, not your sole components like LTRs, the fact that they are made up of what? LTR, GAG, POL, and ENV, they can fight off exogenous retroviral infections through viral mimicry.
Okay, so true or false? All viruses have this function.
I would argue that for the most part, your endogenous retroviruses that have those components have that inbuilt function to fight off exogenous retroviruses.
If you get infected by a virus,
they literally
then that virus will do viral mimicry and prevent further infections by other viruses. Literally all viruses do this.
Here's the
whether
thing,
or not
though.
they're endogenous.
The endogenous retroviruses are tightly integrated into the genomic systems of biological organisms.
Yeah, but
when we have outside external exogenous retroviruses, not endogenous, for the audience, endogenous means occurs from within, originates from within. Exogenous, meaning it's coming from, a lot of people think exogenous and endogenous are the same things. No. So exogenous retroviruses invade from outside, but the endogenous retroviruses exist within the genomic systems of biological organisms. And so when these invasions take place, thank God we have these built-in mechanisms that can fight off these external invaders.
Right,
And
but
so
exogenous retroviruses also do viral mimicry. All viruses exhibit this behavior. If you get infected by a virus and it puts its DNA into your genome, it is going to do viral mimicry and it's going to prevent further infections by other types of viruses. All viruses do this.
HIV, you are arguing, does the same type of functional role that these endogenous retroviruses do?
Yeah, if you have viral DNA, like a retrotransposon integrating itself into your genes, every virus with an LTR, a GAG, and a POL, all that, if it just now injects itself into your genome, it will fulfill this behavior as well. It's all viruses.
An HIV virus.
Yeah, it prevents further infection by like other kinds of viruses. It competes for your host resources.
Well, actually, I think the reason he's saying the HIV virus is because the HIV virus doesn't kill you. It weakens your immune system, which allows other viruses to kill you.
Mm-hmm.
Well, it's not doing what these endogenous retroviruses.
But here's the thing. I don't believe the HIV virus is natural. I do believe this thing is man-made. So
well, I don't want to go down that road. Okay, what I was going to respond with is and I've got paper after paper showing how even some in the secular community are holding to this position now, and maybe I can find it in time. The origin of RNA viruses in general. Okay, we would argue that your exogenous retroviruses, like let's say HIV, they've only got a few genes anyways. Okay, your exogenous retroviruses have actually originated from their respective hosts before they crossed into different species. Okay, and this has to be the case because RNA viruses require a host to replicate. And so the paradox for the evolutionists, and the question I'll ask you, Grayson, is if RNA viruses require a host to replicate, what came first? Well, the RNA virus or the host?
I don't know the origins of viruses.
Right. And so that's why I believe we have a much better explanation for why endogenous retroviruses and also exogenous retroviruses have these very specific components. For example, on the screen, we have LTRs on either side, as you know, GAG, POL, and ENV components comprising it. Well, if your exogenous retroviruses originated from a host, like an endogenous retrovirus, a pre-existing endogenous retrovirus, and then it cross species, then of course it's going to take those genes with it. And so the evolutionist thinking is actually backwards. You guys are thinking that these endogenous retroviruses occurred from outside, originally from exogenous retroviral infection, when in fact it's the opposite. These exogenous retroviruses are escapees from the hosts that they originated in. Go ahead.
I mean, we see viruses endogenize and incorporate themselves into host genomes, so we know the process by which this happens.
But that's dodging the point that I just made about, okay, so here it is.
I already told you that I'm not going to speculate on the origin of viruses because I don't know. So I don't know what you're wanting me to say.
I'm trying to say that the position that I'm putting forth, the VIGE hypothesis, variation-inducing genetic element hypothesis, for the audience, please look at the screen. Origin of viruses here, nature.com. Notice what they're saying. They're saying what I'm saying. To date, no clear explanation for the origin or origins of viruses
That's
exist.
not what you're saying.
Let me keep going. Viruses may have arisen from what? Mobile genetic elements that gain the ability to move between cells. They may be descendants of previously free-living organisms adapted to a parasitic replication strategy.
Sure, that's possible. Who cares? How's it relevant?
It's irrelevant because, again, here, where did viruses come from? These pieces were able to escape their original organisms and infect another cell, as in they originated from, notice this, broken pieces of genetic material inside early cells. So my position is your viruses, your RNA viruses like exogenous retroviruses, originated from their hosts. So basically our model suggests created kinds in the beginning. They're front-loaded with various classes of functional and beneficial retrotransposons, but over time, due to mutations, due to degeneration, due to errors in the copying process and the protein-making process, you get a harmful exogenous retrovirus that escapes from the cell and then crosses into other species. That's where you get HIV, for example. And so
how does that explain the patterns that we see in ERVs across species, like the form?
Okay, but now see, here's the thing. Now we're jumping. Yeah, but now we're jumping to nested hierarchical patterns. I'm trying to tell you and show you why endogenous retroviruses that are integrated into biological organisms, why they have sequence similarity to exogenous retroviruses, the LTRs, the GAG, the POL, the ENV. That's because the exogenous retroviruses originally came from the host cells. And so they took those genes with them rather than the opposite. And that makes sense because, again, as I've pointed out, RNA viruses require a host to replicate. So obviously,
okay, but you don't have any paper demonstrating this, right?
I am literally showing you from the secular literature that they have the same, more or less.
What I'm seeing is might have. I'm seeing a lot of speculation. I'm not seeing any kind of citation showing this to be happening because that's the standard that you want to hold the other evidence.
Okay, so
to, is that
what
you
model
want to
do
see
you hold to
the
then?
actual paper of this happening, yet you do not have this. This is all speculation.
This right here is speculation from your own secular literature. Notice this paper right here: viral evolution, primordial cellular origins, and late adaptation to parasitism. Look at what it says. The virus first hypothesis states that viruses predated cells and contributed to the rise of cell life.
Right, a hypothesis, right?
But this is like from your own literature.
Donnie, from the get-go, you've been trying to hammer on this subject for 5 minutes now. Originally, I said, I do not know the origin of viruses. Right? That's where the conversation should end.
No, it shouldn't end there, because supporting evidence for this hypothesis is the fact that we see these functional roles associated with the integrated endogenous retroviruses.
Well, you've never seen this happen.
Allow
you
them
have
to
no citation showing this happen.
Well, here you go again, Grayson.
You don't have a
citation. Of your sentences are starting in the middle of mine.
Donnie has inference to the best explanation, though.
The point is, what is the most parsimonious explanation? I am showing you that my explanation is also suggested and held to by many in the secular camp, because you have once I'm done talking, you can have as much time as
you never stop talking.
So you argued, Mr. Miserable, you argued, Mr. Grumpy, that you don't know. You pointed out that you don't have an answer for the origin of RNA viruses, but you know that the answer, since RNA viruses require a host anyways to replicate, it makes sense logically, scientifically.
So here's what I do know.
Originated from the host.
Here's what I do know. we have observed viruses insert their DNA into species. We have not observed DNA in a species becoming a virus, right?
You're not getting it. You're not getting it.
Well, you are not providing any sort of evidence.
Put your thinking cap on, Grayson.
Donny,
okay? I've tried to be nice with you.
Damn,
I've tried to be nice with
SAT's
you.
a beast, y'all.
But your grumpiness is actually starting to get on my nerves.
That's good.
Because again, dodge, duck, dip, dive, and dodge, the 5 Ds of dodgeball. That's what you guys are great at, okay?
Yeah,
RNA viruses. Listen up, Grayson. Listen up, dude. RNA viruses. I try to be calm, collected, and cool with you, but clearly you haven't had enough sleep lately, okay? RNA viruses require a host to replicate. You say you don't know the origin of RNA viruses. Well, guess what? Many, even in your camp, are pointing out that this fact is enough for us to suggest. Here's another paper right here that says what?
Dude, it doesn't matter to me where the origin of viruses are. I think they're totally irrelevant for this conversation.
I think you've missed the point, Donny. You've completely missed the point. The point is how, even if it was exogenous viruses changing into endogenous ones, you're still saying that virus that came
I think
from
you got the other way
organism,
around, Mark.
Yeah, if I could just finish speaking. Another organism, it transferred it multiple times, like tons of times, to different species,
randomly,
making this nested hierarchy that is consistent over these species. How did that occur?
Okay, so I want to address these guys. What we're going to do from now on.
I already asked Donny that, and he dodged the question.
I know.
Because we're going to do time responses.
Yeah, we're going to do time responses.
Donny.
We're going to do timed responses because now they want to go on to the nested hierarchical patterns, which I will address. But firstly, we have to acknowledge, guys, we're doing timed responses. Time my response, praise, and then go around the room, okay? It's too late.
Okay, 50 minutes for Donny's response.
Grumpy evolutionist, okay? But make sure that nobody goes over 2 minutes, let's say. If we hit 2 minutes,
I'll warn you
tell us
like
to wrap it up, okay? Okay, so this shouldn't be difficult, evolutionists. You have a very unsophisticated understanding of how exogenous retrovirus infection and how endogenous retroviruses in general work, okay? So again, here from your own literature, notice, suggests that viruses were once part of the genetic material of host cells, but escaped cell control. And they took genes with them, so on and so forth. That is what I'm saying. That's what I've been saying for the... Hey, timed response.
Hypothesis.
So, you have these retrotransposons, these various classes of retrotransposons that are functional in organisms, okay?
You're repeating
yourself. From them, you get your harmful exogenous retroviruses, like HIV, for example. That escapes, that crosses species. Now you have all of these escapees that can leave their original host and then infect other hosts. And so when you have exogenous retroviruses that originated from jumping genes or healthy retrotransposons, yes, if you have, so what Mark is saying, he's not getting the point. If you have an escapee that leaves the genome of its host and then infects another genome, guess where that exogenous retrovirus originated, though? From a host.
Show me an example.
From a host. And that's why we can easily tell that the HIV didn't originate in humans. It came from chimpanzees, and I believe it came from a very specific mouse species where it's not harmful in that so these exogenous retroviruses, wherever their original host is, they don't harm that original host.
So you're saying that all of our ERVs came from other species.
They harm new hosts, those that are infected. For example, us, the HIV virus, the exogenous retrovirus, it did not originate in us, and so it affects us negatively. Go ahead.
Okay, so you're just demonstrating ERVs now, because in light of what you're saying, when we look at the nested hierarchy, which you really don't want to talk about, we can see that even if what you're saying is accurate, and this hypothesis that you've provided no evidence for, and you have no evidence to show any kind of escapees coming out of a host genome, you haven't demonstrated that. But even if that's true, that would still not explain the nested hierarchical pattern that we see, and the fact that we do see a nested hierarchical pattern, even if these ERVs originate in other species, still demonstrates evolution is true because of the patterns that we see across species.
And I'd just like to add that the paper actually gives 2 stages to this. Results suggest 2 important phases in the evolution of viruses. So as I've pointed out in multiple debates, these viral elements themselves are evolving as well. One, origin from primordial cells and coexistence with cellular ancestors, and two, prolonged pressure of genome reduction and relatively late adaptation to the parasitic lifestyle once virons and diversified cellular life took over the planet. Under this evolutionary model, new viral lineages can evolve from existing cellular parasites and enhance the diversity of the world's virosphere. So what it's basically saying is, yeah, even though, but you're missing the main point. And the main point is, even if these were escapees, and we don't know the origins for sure, but sure, if they're escapees, why did they manage to infect all of these different organisms at exactly the same point, when the target point for a virus is completely random, wherever it happens to get a foothold? How did it infect exactly the same points? And why were the viruses, with all these escapees that you're talking about, why were the viruses exactly the same viruses at
Can I answer
exactly the same points?
Let me answer this for you. Let me answer this for you.
Hey, firstly, somebody's really echoing, and I'm not too sure who. It's not Mark. It's not me. It's not Grayson. It might be you, Bubblegum. So make your point and then try and unmute. Go ahead.
Okay, first of all, you're starting with the presupposition there are infections. Secondly, saying like, why are they in the same location? That's like asking, why are the fingernails on a human and the fingernails on a chimp in the same location? Because they were designed in the same location, not that they were infected in the same location. That's all.
Okay, it went Grayson, then Mark, then Bubblegum. So let me go real quick. Okay.
I would like to respond to that after you, Donny, if that's all right.
You know, Mark, go ahead if you'd like to respond, and then I'll go after you.
I mean, I'm not presupposing they're infections. There's long terminal repeats on either side of the target infection side that shows that uses integrase to actually put the retrovirus into the DNA sequence. It's like seeing a scar and saying, well, something wounded that, and you're going, well, that's just a presupposition. You know, don't be ridiculous.
You are presupposing.
And if you want to, thank you. I'll just speak now. If you want to make the case that it was designed that put those elements into chimpanzees and humans, then you'll have to demonstrate that, not just make assertions of it.
I just demonstrated why are the fingernails in the same location.
Okay, I'm going to respond now, equal time, and then we'll go around the room.
You get 2 minutes, SOT. Please do not interrupt, SOT. Go ahead.
Okay, just let me know when I hit 2 minutes, and then I'll just wrap it up, okay? So firstly, we have to focus on what's called fixed endogenous retroviral sequences or unfixed ones, because there is at least 2 papers that talk about koalas currently and how they are experiencing exogenous retroviral infection, where a few of these exogenous retroviruses, okay, they're occurring from outside, they've infected, they've integrated the germ cell line, and they've actually been passed on. And so we're observing endogenous retroviral formation in real time. But what they're finding is your pre-existing fixed endogenous retroviruses, the ones that we would say are created, the ones that are stuck in place, that are shared population-wide, okay, those are actually functioning in the disruption of your newly endogenized retroviruses. And it's killing them. It's destroying them. And so, again, there is an example of your pre-existing fixed ones that we would say are created. That's why they're shared. That's why if you have fixed functional endogenous retroviruses in all of humans, and in that specific location, you see them in chimpanzees, also fixed, then guess what? Those would be an example of a created unit that was original to the host. If you find an unfixed one, let's say you find an unfixed endogenous retrovirus that only a subpopulation of chimpanzees, I'm hearing some background noise, chimpanzees or humans have, then yes, we can say that that was the result of an exogenous retrovirus that was that originated as an escapee that infected and got passed on, but it'll be unfixed. And that's how we know, because Mark asked, how can we know? Last thing I'll point out, LTR functionality. The majority of retroviral-like sequences that we find are not your complete ERVs that function in fighting off viral infections, okay? Which is why they need those components, including your integrase, your reverse transcriptase, so on and so forth. Your solo LTRs are what comprise the largest portions of the genome. And right here, there's at least a couple papers where you have LTRs functioning as promoters. And so even those demonstrate function. And I'll yield. Thanks.
Yeah, so that doesn't really answer the question of how they actually got here. It sounds like you're trying to say the fixed ones, and we so to explain, fixed are the ones that become a part of the normal genome of that organism. So the ones that are fixed were placed there by some sort of designer, while the unfixed ones are these escapees, which sort of contradicts what you were saying earlier. And the fragments of the fixed ones that are already there still have the LTR regions. We can tell they were infected by them. So in some way, what you seem to be saying, and correct me if I'm wrong, is that some kind of deity put these fixed ones there, added things like the LTR regions in order to make it look like that organism was infected by a retrovirus, and somehow did all of this for, well, I don't know what reason. The alternative explanation is that a common ancestor was infected by the same retrovirus back when they hadn't diverged off, and because that was infected and the DNA sequence became that retrovirus became fixed within the genome, when they split, both organisms kept the same replicated virus fragment, including the LTRs where the transcriptase had made that cut in order to integrate itself into the DNA. Now, I mean, you can believe that a god sort of pretended to make an integrase cut for some reason, but that sounds highly improbable next to the much more plausible explanation that a common ancestor was infected in the germline, that retrovirus mutated, became beneficial, the sequence was kept, and that split off into two different organisms, keeping the same position and the same virus in the same spot, including the LTRs.
Okay, I appreciate those points. And those are some worthwhile points to discuss. Firstly, I think the biggest problem is the evolutionist mindset when it comes to viruses in general. And so right here, you can see from BBC, there's a number of, this is an article, but there's a number of papers that go over the fact that most viruses in general, the vast majority of viruses are not pathogenic to humans, and many play integral roles in propping up ecosystems. So basically, you wouldn't want to live in a world without viruses and also bacteria.
And that's a quote from an evolutionist, right?
Of course.
Yep.
So there's a lot in the evolutionist camp. And notice how I didn't interrupt Mark, though. But Grayson, you can go next. Okay.
I truly don't care.
That's okay. Well, then mute yourself and let me and Mark go at it, because at least Mark's willing to have an equally timed, cordial discussion, which is less exhausting. Okay. So the issue is the hosts, again, RNA viruses require a host to replicate, or else how are they going to replicate? There's a paradox. And that's why there's some in the secular community now that are even suggesting what a lot of creationists would suggest, that a lot of your viruses have originated from the hosts and maybe have even originated as escapees from mobile elements. And we know various classes of retrotransposons are mobile elements. So again, you have hosts that predate the exogenous retroviruses, and integrated into the hosts are endogenous retroviruses, but also other classes of retrotransposons. Now, this is where I want the evolutionists to pay attention. And so these endogenous retroviruses, let's stick with those, they comprise what? What makes up an endogenous retroviruses? LTRs on either side, long terminal repeats. They are functional components to the endogenous retrovirus in the same sense that my two legs are functional in the unit that makes me a human being. In the middle of your endogenous retroviral unit, you've got your GAG, your POL, and your ENV gene. They are also necessary components to the endogenous retrovirus, okay? Those components in general are needed for this functional role, for example, how they fight off exogenous retroviral infection. So again, the evolutionist has the opposite, the backwards understanding. Your exogenous retroviruses are originating from the hosts, and those hosts have pre-existing retrotransposons that are made up with these LTRs, GAG, POL, ENV. And so these pre-existing ones, especially the fixed ones, they are not the result of outside infection that is bringing in these components. It's the opposite. Your escapees are taking those components with them, and they are now jumping from organism to organism. And so everything Mark said, it's backwards thinking from what the escapee hypothesis is actually suggesting. Go ahead.
That cannot be true. And I'll explain why that patently cannot be true. It's because, and you're right, the LTR regions are there, and that's the main thing. Because LTR regions are created when transcriptase actually makes a cut in integrase makes the cut in the DNA in order to insert that retroviral element into it. So the whole idea that they originated from this host, and don't forget, and here's the really important part, when the virus uses the host's resources to replicate itself, it does not, like its viral sequence, the ENV GAG pol sequence, it does not include the LTR in that. So what it does is it replicates the ENV, GAG, and pol sections, and then that viral element goes off, finds host DNA, makes a cut with integrase into that DNA sequence, and that is what causes the LTR in that new organism. So whenever you're pointing at something that has LTR regions, which you acknowledged yourself, that made up the viral element in these organisms, you are basically saying that has been infected by something else. Now, I'm not saying that there isn't an origin host somewhere. We don't really know the origin of, and your paper sort of said, we don't really know the origin. It could well be an escapee. But the whole idea that you're pointing to a viral element with LTR regions shows that it's an infection. So unfortunately on this one, Donny, you're 100% wrong, because that viral element will not replicate those LTR regions. The only way they get into the genome is through the cutting of DNA, and that's basically where they come from.
Okay, so my turn to respond. I appreciate that. So in the same way that Mark says I am 100% wrong, I would argue that he is 100% wrong on this. Okay, so notice on the screen, the long terminal repeat element of an ERV. Again, we have your LTRs, your GAG, your pol, your ENV. They are functional components of the unit called endogenous retrovirus. In the same way that my legs, my two arms are functional components or elements of the unit that makes me a human being. My legs, my arms didn't originate from outside somehow. Okay, they're part of me. So notice this: has the capacity to exert regulatory influence as both a promoter and enhancer of cell genes. Yes, escapees can take these genes with them. That's why your exogenous retroviruses are made up of the same components. And the endogenous retroviruses require those components anyways, because one of their functional roles is to fight off the exogenous retroviruses. And they also function in tumor suppression, for example. And that's done through viral mimicry, where basically an endogenous retrovirus is turned on. And so the immune system, the body's immune system, targets that cell with destruction because it sees that cell as being a damaging or harmful virus, when in fact that's not the case. The endogenous retrovirus is using viral mimicry. It requires the LTRs, the GAG, the pol, and the ENV to carry out that job. That is evidence of forward thinking, which points us back to the forward thinker that Mark wants to reject as being the entity that front-loaded biological organisms with these created units of DNA function. Okay.
Okay, Donny, can you stop dodging and can you address what he said with integrase? Whenever integrase functions on the DNA, it leaves behind a telltale sequence.
Yes, I have that written down. Listen, Mr. Grumpy Pants, I have that written down.
Donny.
I'm addressing
man,
everything.
So
Praise. I didn't interrupt Mark. We have Mr. Grumpy who's going on 10 hours of sleep.
So, Grayson, you can just get in line, man. Like, if you want to talk, just say, "Hey, I want to speak," and then we'll wait for you, your turn. We'll give you time. So
I did think Donny was done. I was trying to wait for him, but he just goes on and on and on, man.
Well, here's the thing.
Still under time.
Listen, Grayson, why don't you go to bed? Because me and Mark are big boys. We're having a big boy adult conversation here. He's actually bringing up sophisticated arguments in a cordial way. You, Mr. Grumpy, even admitted you're Mr. Grumpy. Sit on the sidelines. Me and Mark can do this all day, okay? I've got
Okay,
things
sure.
written
Can you
down.
just
Mark
address what
talked
he
for
said
3
about
minutes
integrates?
straight, and I'm trying to address everything, okay? This idea of the integrace, every single aspect and component of the endogenous retrovirus, including the integrace, is essential for its many roles, including the fact that many of these units are called mobile elements, meaning that they can move from one chromosomal location to another, and they do this through copy and paste means. And I've got 500 slides here. I've got a number of papers that talk about how when they move from one genetic location to another, guess how they do this? Copy and paste. This requires the reverse transcriptase. This requires the integrase.
So
And
that's
so when
perfect.
you guys talk about, I'm not done. When you guys talk about the scars that are found in specific genomic locations in biological organisms, you're assuming that they got there from outside infection, when in fact, many of these retrotransposons that pre-exist in the organism, they're integrated in the organism, they can move around. And
Okay,
every
no, that's
time they
perfect.
move around the genome, they leave these same scars.
Okay, yeah, I hear you. They move around within the genomes using integrase. Okay, perfect. So now explain why they're all in the same location in organisms that are closely related to each other. If they're moving around, then it would have to be a total coincidence that they're all in the exact same locations in closely related organisms.
Okay, so
That's true.
firstly, okay, we have what's called target site duplications, where I've had a whole discussion with Andrew on this. When they do move around, or as you're saying, an external exogenous retrovirus integrates, okay, the whole point of reverse transcription, it's transcription, DNA to RNA to protein in reverse. And so it has to do that to integrate its RNA material basically into the genome. Okay, and it integrates, uses integrase. It's the same thing going on when this occurs within the genome, but because it plays an important role in, for example, variation, gene expression, but the variation, I would say, is one of the most important functions. And so it actually has preferential, there are sites that are preferred as locations where these mobile elements can jump to.
So
And
there's
so
like basically,
a functional mobile element in humans will be jumping to those preferred sites in the same way that those mobile elements in chimpanzees are also jumping to those preferred sites. An analogy, and then I'll wrap it up. Mark can take as long as he wants, okay? These scars are only assumed by the evolutionists to have come about and to have been put there from external infection, when in fact, this is the same scar, this is the same signature we would expect from internal integration. And your target site duplications, we can compare that to, let's say you're a pilot and you're flying your airplane, you have your, where you're going to land, your landing strips. And so that's the preferred site to land on for your plane. That's basically telling you, hey, this is where you need to land your plane. And there's many of those sites in the genome that says, hey, mobile element, this is where you need to land in order to induce variation, for example. So there's a lot there. Go ahead, take your time.
so it's basically
Yes,
a docking, because you can't land the plane in the freaking terminal. You have to land the plane in the terminal. You can't land it where the people are eating. Anyways, I gotta go.
There's tons and tons of target sites throughout the humans, and while you can claim there's specific sites that it prefers, you haven't demonstrated that in the slightest. I don't know how you're going to demonstrate that. Like you haven't. This doesn't say there's preferred sites in the process. It says that it doesn't know how much. Like, you can't just take a paper that says we don't know something and then insert your own conclusion, which is unfortunately what you do a lot, Donny. LTRs are actually a mix between transposon and non-retrotransposon regions. So it is when the integrase makes a cut in there. It does not duplicate those LTR regions when it propagates. And that's one of the things that you're absolutely missing and you seem to want to talk around. Like if this was done in order to like you seem to think that it will not create these LTR regions when it propagates, and it does. Even if you like it's propagating throughout one organism, why it ends up in the same region over multiple organisms is basically just a statement by you that it goes for that region, where there is nothing to suggest that is actually the case. Absolutely nothing. You said that like they're not pathogenic to humans. Some are, some aren't of retroviruses. The endogenous retroviruses, if they were pathogenic, they wouldn't be passed along. The organism would die. And that's sort of something that you bring up these objections, which have nothing to do with the actual case that evolution is making. The whole idea that they can originate from the host yet only end up in one region, even though there isn't really a process in which to correct, like to get rid of a retrovirus element, is kind of weird. If you think that they came from somewhere else in the organism, instead of an infection in the germline of the organism, why are they always in the same place? Why are they always the same virus? You haven't actually addressed that. You've sort of brought up things that don't have anything to do with it, like the beneficial nature of retroviruses. Yes, they can be beneficial. They can mutate and become beneficial for humans. It's called co-option. I know that you've brought up a few papers that outlined co-option specifically. And the paper that you had of the role of human endogenous retroviral long-terminal repeats mentions evolution in it. ERVs have evolved to serve an important function in the physiology of their human hosts. It's saying that they evolved. Like, so why you're using a paper that not only says that humans evolved, but retroviruses have evolved to be beneficial, I don't think that provides very strong evidence for your case. All it is doing is bringing up a paper that disagrees with you.
Yeah.
Okay.
Donnie just scrolled through 300 slides to try to find one source, and he couldn't find one citation to demonstrate this preferred sites for transposons.
I actually I found exactly what I was looking for. So I've got everything written down that Mark said. And so I want uninterrupted time. I haven't interrupted Mark once. And so that's what I appreciate. And so I've got everything written down. I'm just going to kind of go randomly. So you talked about how these beneficial functions in determining cell types in the placenta, acting as antiviral protectors. We could go on and on. You say, well, they can mutate and they can evolve those functions through co-option. I mean, that's evolutionary philosophy that's based on evolutionary presuppositions. It's an assertion. It's a claim without evidence. Never once has it been demonstrated what is claimed in these papers, okay? We need to learn how to critically think. We care about the data. We don't necessarily care about what the authors conclude in terms of their hypotheses that are untested or the guesses that go into explaining the data. We care about the data. And what's the most parsimonious explanation in light of the data? It's that these are created units of DNA function, since I have paper after paper that literally talks about, for example, this one here. Notice this. If the accidental infection of a mammalian ancestor, so here's what Mark will do in his bias as he reads this. He's just going to blindly believe that the claim here, the accidental infection of a mammalian ancestor, even though that's never been observed, it's never been observed today that you have a harmful exogenous retrovirus that infects, integrates into the germ cell line, is passed on, its harmful effects are destroyed through a series of mutations, and then it's able to evolve the functional ability to be essential. Whereas this says, notice this, if this had never occurred, they're assuming that it occurred, the placenta and mammals that produce it, including humans, would have never existed. I like to exist. Mark likes to exist. Grayson's a little grumpy. Maybe he doesn't like to exist tonight. I don't know. Hopefully tomorrow is going to be different.
We've seen placentas without syncytin.
I knew that would trigger you.
In
Who cares?
reptiles, we have seen placentas develop that
You
do
know
not
what? We've
utilize
seen. Hey,
ERV
praise,
syncytins.
please moderate. I'm trying to address all of Mark's points.
Come on, Grayson. Let me finish. We'll let you speak here, Grayson, next. If
I'm
you
going
want.
through every point. And here's the
Right.
thing. I bring up a lot of points because I'm responding to Mark, and I let him take as long as he wants to. It's called take out a pen and paper and write down the points, which I don't think Grayson ever does. Okay. Nope. That's why you get grumpy when you're getting schooled in a debate.
I've
You're
been
just burying yourself in a
That's
hole.
true, Grayson, because when I whoop your ass in quantum mechanics, you better not be doing this, boy.
Look, I think we're getting into meta stuff and getting off the track here. You know, I think you're just trying to trigger Grayson now, Donny. Your time's running out, mate. Use it wisely.
Okay, here we go. So we're gonna move on here. I'll just say real quick, because I don't like to leave any stone unturned. We have some vehicles, believe it or not, that have a backup camera and a navigation system, both functional components of a vehicle. And then we have other vehicles that don't have a navigation system and a backup camera. Apparently, that means they evolved from a common a common sedan ancestor in the Arctic. It doesn't make any sense. These things Grayson talks about.
Yeah, it doesn't make any
moving
sense.
on. Oh, here we go. Mute yourself, Mr. Grumpy. Okay, so your next thing was, why are they all in the same place? Why do they fit this perfect nested hierarchy? That's not true. I mean, here's one paper in general that breaks the hierarchy. We've got HERV-K, provirus in chimpanzees, bonobos, and gorillas, but not in humans. These observations provide very strong evidence that for some fraction of the genome, chimpanzees, bonobos, and gorillas are more closely related to each other than they are to humans. And so, yes, overall, I will agree there is a nested hierarchy. I'm not going to disagree with that. Humans and chimpanzees are a lot more alike in genetics, anatomy, morphology, and physiology, and in endogenous retroviruses than a human is to a fish or a dog. Okay, that's what we would expect in both models. And then you also talked about the integrase again and the functional components. The functions that these retroviruses, the endogenous retroviruses perform, require these elements, including the integrase. When they move around from one chromosomal location, okay, so it's in one chromosomal location, it moves, and so it turns a gene off or on, inducing variation or inducing some other kind of function. The integrase is necessary for that. And so,
can I ask Donny a clarifying question about that last point?
Yeah,
sure.
So, why for the syncytin gene specifically, why does it need an LTR, a GAG, and a pole? You said that those are necessary elements for its function. Why couldn't syncytin just be a gene by itself?
Well, it depends. If we're looking at an endogenous retrovirus that comprises the syncytin gene in order to function in placental development, well, that would be that specific endogenous retroviral unit's function.
Yeah, but it doesn't need a GAG or a pole or an LTR to do that function. You said that those elements are necessary for its function, but that's not the case in syncytin.
But it is the case when it comes to acting as antiviral protectors. It is
which
the
syncytin
case.
Doesn't do. I'm asking specifically for syncytin, which does not do viral mimicry. Syncytin is used in placental development, but LTR, GAG, and pole do not play a functional role in syncytin's role.
You're saying that your endogenous retroviruses that act as antiviral protectors, you're saying they also comprise syncytin. And so why is it there, basically?
No, I'm saying syncytin does not do viral mimicry. It doesn't.
But
the LTR,
but it does act
in
but it acts in embryological development.
Yes, syncytin does, but it doesn't use the ERV functions in that role.
That's right. Yes.
Because that specific, so for example, HERVs, notice here, okay, there are different classes. There are different classes of retrotransposons. The ones that function in embryological development, they require syncytin.
I feel like you're not listening to what I asked.
So Donny, let's see if I can clear this up and sort of make something. So can you acknowledge that in order to perform their function, not all ERVs like syncytin needs the entire viral element, including ENV?
Right. Yeah, I've always argued that.
Okay, that's basically Grayson's point, because you did say that it requires the entire viral element in order to perform its function.
It depends what functional role we're talking. If we're talking about moving from one chromosomal location to another and therefore inducing variation, then yes, it's going to require the integrase. It's going to require
Well, yeah, of course.
the reverse
That's why I specifically.
but it won't
asked for
require the
syncytin.
syncytin.
That's why I specifically asked about syncytin, because syncytin doesn't move around in the genome. Syncytin doesn't do viral mimicry. Syncytin has a function that does not depend on its ERV sequences.
Okay. But
And
the
I'm glad you
ERV,
brought up
but the ERV
syncytin.
unit that has syncytin functions in embryological development. That is its assigned role.
Sure.
So what?
And do you know, I'm glad you brought up syncytin. I do want to sort of address some of the things. You talk about the many papers that you have, and the problem is, Donny, they all talk about evolution. Like you can't sort of quote a paper that disagrees with you and then say, well, I'm taking the data out of it, but I'm not paying any attention to the conclusion. It's the people that have done this work that have put the conclusion in there for a reason. And you've sort of said we've never observed, this happen in evolution. We've never observed a god put a viral element into something or create anything at all. We've never observed that either. So I think there's a different level of sort of evidence that you want for your god claim as opposed to the evolution, sort of evidence that we give, because we never get any evidence of a god doing anything. That's the problem. So, sort of, it's not an alternative explanation because we never get anything on it. You sort of said, well, we like to exist. That's just an appeal to emotion, mate. Whether we like or dislike exist has got nothing to do with whether it is true or not. It's just, an appeal to your emotive thing of we like to exist, therefore this had to happen. That does not follow. Now, I'm glad you brought up syncytin because wallabies and metratremes, do not have syncytin. They do not have it. And what we can see is the SIRH family, like PEG10. PEG10 is in both marsupials and eutherians, but it's not actually in metratremes. So we can tell that the PEG10 SIRH family of retrotransposons was inserted after marsupials and eutherians branched off, but before animals in general branched off. So metratremes, they basically lay eggs. They do not have syncytin. Neither do marsupials like kangaroos, wallabies, and all of that kind of thing. They actually use a yolk sac placenta, not the umbilical cord placenta like the rest of the eutherians do. And you've got to somehow explain why that syncytin lines up with where exactly we think these animals diverged from one another, why it's in exactly the same place in all eutherians, why it's exactly the same origin virus in all of eutherians, and why if something went around putting these in, why they didn't do the same for marsupials and monotremes.
Time.
Okay, so there's definitely a lot there. I'm gonna have to ask some clarifying questions on the last several points there with monotremes and different creatures and different variations of syncytin, the syncytin element. Would you say, Mark? I'm going.
Yeah.
Okay, I'll address your first points. Okay, so what we can do when we read these papers, sometimes depending on what we're looking at, the conclusions and the discussion portion of these papers, they may have some good empirically verified or validated explanations. Other times, not so much. When we see these functional roles associated with these endogenous retroviruses, for example, this specific one where it literally admits we didn't have this specific endogenous retrovirus, we wouldn't exist. But we're going to need, in the same way that Mark says, well, we've never actually seen this god or a designer create biological organisms with these functional units of DNA. I say it's the evolutionist philosophy that harmful exogenous retroviruses actually manage to integrate in the right way to be passed on. Firstly, we see and I had the paper up earlier, but I've got too many slides here, and I don't want to take too much time. These koala pre-existing endogenous retroviruses, they are being called upon. They are now active as we see these newly endogenized retroviruses, and they're being destroyed by the functional fixed pre-existing ones. The ones that are basically the antiviral programs. Just like our computers have built-in antiviral programs, so do biological organisms. And so we see when there is a case of an actual endogenous retrovirus, the result of an exogenous retrovirus, it's destroyed by the pre-existing ones. And so again, we would predict the ones that are created by the God that Mark wants to reject would be fixed, as in they're stuck in place. Every single human has them. And if it's functional in, let's say, determining cell types, then it may be found in the same spot in chimpanzees, and it'll also be fixed. Okay,
You
but it'll
didn't
be
answer
pre-existing,
anything that he said.
and
Yeah,
it'll be pre-existing.
You
Okay?
didn't answer any of his points.
I've literally got his points written down, and I'm going one by one. And so it's his evolutionist philosophy to say that these functions were co-opted. So he's making assertions and claims that we've never seen a designer integrate these functional DNA units into biological organisms. But again, this goes back to what we were talking about earlier. RNA viruses require a host to replicate in the first place. And so we as creationists, we don't have that paradox. We don't have that problem. Now, the last point he was making in terms of syncytin basically being found in some creatures and not in others, Mark, I'd like you to reiterate a couple of those points so I don't misrepresent your argument. So go ahead.
Oh, that's okay. I'll reiterate, and Donny can go, because I want to clarify for him. So humans, we have syncytin 1 and 2. In other eutherians, we have syncytin A and B. They're basically analogous to one another, kind of thing. Marsupials do not have the syncytin retroviruses. So basically, humans have the PNA family, like PNMA 1 to 19, that have the SIRH family, which is sort of PEG 11, and SIRH 3 to 11. That's in all of those, from everything from an elephant to a human, basically. That's where those retroviral elements are. In the same place, same virus element. So there's the SIRH family, the PEG 10 family. So none of the other ones that are in humans and other animals are in marsupials, right? They don't have them, but we share with marsupials SIRH family PEG 10, right? So the PEG10 retroviral element, we have that in both marsupials and other eutherians like humans and elephants and all that kind of thing. But what we don't have is so the monotrines do not have any of that, right? They have none of them. So what that, and this is what we were trying to get at the nested hierarchy. Either a god went and decided to put this placental development thing, made it look like a virus, put it into these organisms specifically, put a nested hierarchy, so it put some in later on, or in some of them, others in not some of them, and then it made it look like there's a nested hierarchy of branching organisms that are going out from one another. I just want to add, like, I'm not assuming that this is the case. Most of your papers that you're citing says that they were co-opted. I'm not assuming them. You must acknowledge that most of the papers that you cite say that retroviral viruses evolve and that they are co-opted by humans.
Okay, I appreciate that clarification. I wrote down as much as I could, and I think I fully understand your point there. Starting with the end there, yes, these papers, of course, are not going to conclude, well, we have these specific classes of retrotransposons that function in determining cell type in the embryo, and we don't actually have any observable evidence or empirical evidence today of these types of functions evolving or these types of co-option events taking place, and therefore they must have been designed. I mean, that paper is going to be rejected right away. So obviously they have to say, well, these are motors of evolution, or, you know, the accidental infection took place in some early mammal. But the thing is, these are assertions. Read the papers. They're untested hypotheses. It's a storytelling a lot of the times. It really is just imagination. It's fascinating that so many evolutionists just blindly believe that these DNA units that are necessary. I mean, they literally admit if we didn't have this HERV element, mammals wouldn't exist. And so I want to move on to what you said in terms of so humans. So basically, Mark, what you're saying is we find different variations of syncytin. Humans being a mammal, other mammals have syncytin, but it's a different variation of it. And some creatures like monotremes, correct me if I'm wrong, don't even have syncytin. Is that what you pointed out, Mark?
Yeah, they don't have placentas.
And they don't. Well, marsupials don't have placentas.
Monotremes
Right.
They
are
have
marsupials.
yolk egg sac.
Right. Okay. So some creatures, the ones that don't have placentals and therefore don't require the syncytin,
There are also
don't have
examples of animals
Well,
with placentas that do not
I'm
have
trying to address
syncytin.
the points, Grayson. But why should that be surprising? So if the syncytin is necessary in the endogenous retroviral units that
It's
function in placental development,
It's not.
but creatures without a placenta don't have the syncytin that's required for placental development. Why is that a surprise?
Because there are creatures that do have placentas that do not use syncytin, like lizards.
Yep.
Okay, so you're saying there's lizards.
Yeah, there are species
With
of lizards that do have placentas that do not use syncytin. So there you go. It's not necessary for the design.
Okay, so you're gonna connect evolution to that observation, and what I see here is we have different variations of syncytin. A lot of different creatures, especially mammals. Obviously, that one paper talks about how it's widespread in mammals, this function associated with placental and embryological development. We find variations in syncytin. We also find some creatures don't have them. Most mammals do. All mammals do, as far as I understand. Okay, well, it's exactly what's expected from the design hypothesis. Right here is a basic phylogeny where we would have humans that may or may not have shared DNA sequences with other creatures that we would point to as being the result of independent creations. And I know you guys hate when creationists look to cars, but again, we have some cars that are built with navigation systems, some are not. We have some cars that are built with safety mechanisms, others are not. We have some cars, the Volkswagen Jetta, some of them are built with a diesel engine, some of them with a regular engine. Well, what does that prove? It doesn't matter. It's all of these components, regardless of what we look at, cars with X component and cars without X component, they're still there for a functional reason. And so variations in the design world, man-made designs, we also see that in the biological world.
And they all have different designers.
No.
Well,
when it comes
I'm glad you brought up cars. I really am.
Go ahead.
I think it's a terrible analogy. So because cars, where they're manufactured, they're not breeding organisms that replicate. So if cars were a breeding organism that replicated, I don't even know how you would make that work. Like it's a weird thing to sort of point to something that is designed then manufactured by humans and making it analogous to something that happens without any intervention, apparently by outside sources, and just breeds among itself to produce copies and variation within those copies. Because you still believe in microevolution. You still think that we can breed dogs to make different kinds of dogs. So the whole thing is you cannot take a car that's been designed and breed it with variation, because you still admit that variation exists. So the analogy is highly, highly problematic. There's no analogy to be had there. The fact that things have the same parts in cars isn't necessarily due to its design. It's to do with the manufacturing process. They're manufactured to have the same types of parts in them. And you get custom cars or concept cars. that have completely different parts than anything else because they're designed as a concept. The analogy is terrible, absolutely terrible. And I think you really should drop that from Hovind because it just doesn't track. These papers that sort of say that evolution is true, of course they do. And papers aren't, you sort of suggested that they'd be rejected for saying that it was a common designer kind of thing. They would be rejected, but not necessarily because they're against your worldview. They're rejected because a paper that sort of wants to say there's a common designer, you would need evidence of that, evidence for that hypothesis. And it seems like all that people can put together is saying, well, we don't believe the evolutionary model. And that's fine. I mean, you can say that if you want. You can not believe it if you want. But in order to publish something in science, you've got to provide your evidence for your hypothesis, not against some other hypothesis out there. That's the way it works. So that's why they're rejected. It's because they don't have the evidence to back them up. And all of this does, it's kind of, you're forgetting the nested hierarchy. So there are other retroviruses that both humans, wallabies, platypus, echidnas, koalas, retroviruses that we all share in exactly the same place and exactly the same family of virus, which suggests that when we were all the same lineage before the split, it was a retrovirus infected the germline. And this whole idea of fixed, like it was fixed because, that's what God made it as, or whatever. I'm not sure what you're saying there, that the ones that are fixed are the ones that he decided were going to be there. No, a fixed one is just one that has been beneficial, and so it has propagated to the rest of the species, and so becomes a normal part of the species genome. Evolution doesn't need to just because it's beneficial is the reason it becomes fixed, not that something decided that it would be fixed and put it there.
Okay, there's a lot there. I've basically got an entire page worth of notes on that one. So how much time do I have, Praise?
I gave Mark about 4 minutes there. We'll let you go about 4 minutes.
Oh, sorry, I do apologize.
Well, that's fine. That's okay. No, we'll let you get your points out. Yeah.
It's a detailed discussion. So you know what? For this one, I'm going to put my timer on 4 minutes just so I know I'm not spending too much time on one point. So I guess we'll start with the end. It's just so much evolutionary philosophy, so much storytelling. I mean, fixed into whole populations. Just saying it like without the acknowledgement that firstly, fixation rates are incredibly slow. Okay, all of these fixed ERVs, with most of them comprising the units that are functional, would therefore have to evolve that novel function, that beneficial function, from exogenous retroviral harmful infections that integrate in the right way that I've pointed out. They're passed on. The harmful aspects of these viruses are destroyed through mutations, and then they evolve these abilities. I mean, that is a lot of imagination right there. Mark said that, I should drop these explanations. Mark needs to be the one who drops these just claims, these blind claims of co-option, motors of evolution. I mean, just read the papers and you can see that they're not providing any evidence for the data in terms of suggesting or demonstrating how these functions can come about. Again, the pervasive retrotransposons that populate the genome have a powerful capacity to influence genes and chromatins. That's what we know. That is one of the many functions associated with these endogenous retroviruses. Now we have, without evidence, an assertion or a claim that these functions were co-opted or came about over millions of years, or mutations deactivated the harmful aspects of them, and then eventually they were able to evolve novel function and fix. Fix just means to be stuck in place, where you've got this ERV sequence that is stuck in place in a specific genetic loci in all of humans. And then we share that with chimpanzees. Well, if it's functional, again, in determining cell types or in embryological development, then of course we would expect these genomic elements to be shared. That's common design. They can say common ancestry, but again, that's evolutionary philosophy. It's storytelling. There's no evidence for that. And so the other point he makes here is, of course, they hate how relevant design modes of transportation are. Okay, adding reproduction just adds more complexity and more problems for the evolutionists. They misrepresent our model. I mean, if I had $1 for every time I had to correct this misrepresentation and straw man of our model, I'd be a billionaire. Okay, we are starting. Everybody has starting points. Everybody has basic presuppositions, and we start from the book of Genesis and its account of origins. And the Bible tells us that God creates man in his image. And so we predict that there must be something about us that reflects the divine. And so when we look to the biological world, we would therefore predict that we should get a sense for how God designed based on how we design. So it doesn't have to do necessarily with sexual reproduction, the fact that cars can't pass on their genes. Humans aren't purposefully, I should say, building in nested hierarchical patterns in order to have an analog to the biological world. No, this is just happening accidentally. And I just hit the 3-minute mark, so I have 1 more minute, okay? So that is our position. This did not have to turn out to be true. And so, yes, when we look to the biological world, it turns out that humans fitting in with primates. So humans and primates share a lot more in terms of morphology, anatomy, genetics, and physiology than humans do with insects. Let's say some invertebrates. Or to make it easier to understand, humans and chimpanzees share a lot more with each other than humans and dogs or fish. And so we would expect, here's the last thing I'll say, yes, this is the way we design in nested hierarchical patterns, in homologous patterns. We even build some interesting mosaics. And this is what we see in the biological world as well. It matches up so perfectly. And so, yes, humans do share more endogenous retroviruses with chimpanzees than they do with dogs. This is not a big surprise. I yield.
Wow. Okay. Yeah. So I think, Donny, I think it's beneath you to get into sort of preaching. It's sort of nothing to say there, really. This whole idea that there's no proof of endogenous retroviruses being co-opted by humans. Your own papers, Donny, say that it's been co-opted, and they point to older papers and parts where we found out they have been co-opted, and we've traced the evolution of not only animals, but these actual retroviruses. We can see where they have diverged. We can see the mutation in the genetic genetic sequences that have gone throughout animals. And you haven't addressed anything I've said at all. I've noticed that you've sort of brought up more points, not actually addressed mine, because somehow you've got to explain why these viral elements are in older or what we call more basal animals, and then it splits into a nested hierarchy. You haven't explained that at all. You haven't explained why it has the LTRs, which show that the viruses have infected that sequence of DNA. You haven't shown that they seek out any part. And this whole idea that yes, fixation is slow to happen. Endogenization happens first, which means that it is passed down vertically. And it only takes one fixation in order for all the rest to die out. That organism survives, and then that organism becomes the normal genome for its species type. And I think you miss that you think that, oh, all of these things running around, it has to interbreed with all of them. No, that's not the case. Just enough have to die so the ones that have that mutation survive. And it's sort of a mistake you make all the time. Then that is fixed within that species when it is the only sequence that is then available. And yeah, it takes time, but luckily we've got enough time to explain it. So that's fine. You haven't, and the whole idea of cars being analogous to organic creatures. We've never taken a car, bred it, and then found we could produce a different type of car. That's never happened. If you could show me that happening, you'd maybe have a point. But unfortunately, I can take a dog, I can breed it and get a totally different dog with a different genetic sequence. I can do that. If you can do that with a car, breed a car to get a different genetic sequence, you may have a point, but you can't. because they are not analogous. They are just not. So that's why it is a poor analogy.
Really quickly,
This isn't
whenever there's time, can I read an excerpt?
great. Sure.
Yeah, well, you're
sure,
out of
Grayson,
time
no
though,
worries.
Mark, too. So
Well, I'll just say
do.
that evolution is not a philosophy; it's a science, and you're reading from science journals. That's how you can tell, Donny.
Yeah, so speaking of, I wanted to read from the exact article that Donny had said does not talk about the evolution or the like how these ERVs formed. This is the exact article that he said does not make mention of this, right? So I will read directly from like the second sentence of that article that he is pointing out. Jumping retroviruses nudge TADs apart. This is the exact thing he said they do not address in the article. And it says in sentence number 2, during evolution, many ERVs have been co-opted for critical cellular functions. That's the second sentence in the paper.
Okay, how much time do I have, Praise?
We'll give you about 3 minutes because you had Grayson add to it. So you can address Grayson and Mark if you want.
I appreciate that. I got everything written down. Grayson, you got to get some sleep, man. That was embarrassing. So Grayson just proved my point, and obviously, as usual, what I said went completely over Grayson's head or understanding. Yes, I have pointed out over and over again. Go rewind the video, the exchange. Yes, they do say things like these are motors of evolution. They've evolved over millions of years. They've been co-opted. Those are claims. Those are assertions. Those are evolutionary fairy tales. There's no evidence for this. We have not seen this in real time. There is no empirical verification of, or else you guys would give me a paper, except a virologist, Dan Stern Cardinal, admitted that this takes too long and we've never observed a harmful exogenous retrovirus integrate in the right way, be passed on. We already see what takes place in the koala pre-existing ERVs when this happens. The pre-existing functional ERVs destroy and attack the newly endogenized retroviruses. But you guys want us to believe, because this is all a fairy tale, a lot of imagination, hope, dream, and imagine, that harmful exogenous retroviruses are going to somehow evolve an ability that without it, we would not exist. So yes, I know these papers say, oh, they were co-opted, and that's it. That's a claim without evidence. But you guys blindly believe in the claims without evidence. Going on to Mark's point, no, you can't see where they diverge. Again, evolutionary-based assumptions and storytelling. He talks about how you can see the mutations. No, you can't see the mutations. It's the evolutionists that are assuming that every single DNA difference is the result of mutations over time. This is evolutionary philosophy. Okay, there is no evidence that in your fixed ERV sequences that are beneficial, they are found in every single individual within the population, and you have what appears to be a mutation. It is the evolutionist that is assuming those are mutations. The creationist assumes that the majority of DNA differences are actually the result of design diversity. And so they are a created difference, and a prediction of that would be function. And yet that's what we find more and more every day is functions associated with these created units of DNA function. Who cares? Again, with what are you saying? Who cares if they are said to have been co-opted? We need to see empirically how this is possible. Don't just give me a story. Okay.
I can show you.
I'm not done. This is equal time. The nested hierarchy that Mark keeps talking about is a side effect of the fact, and this brings us back to the beginning of the conversation, that retroviruses have originated from within the genomes of their hosts. And so, yes, we expect there to be a relative hierarchy where we have humans and chimpanzees sharing more endogenous retroviral-like sequences than humans and a dog. Just stand back and look at the overall morphology, anatomy, study the physiology. Of course, this is just basic. The word basal that Mark used, that's riddled with evolutionary base assumptions. He is assuming that pre-mammalian ancestors without syncytin was an organism that had not yet evolved it, or let's say a line that did not experience the newly evolved ERV component. That's all based on, again, evolutionary philosophy. And then the last thing he said, and then I'll be done. Again, the claims of fixation is philosophy. Time is not the hero of the story for the evolutionists, okay? What do we know empirically? Fixation rates are slow, too slow. Beneficial mutations are also rare and too slow to fixate. We actually see in the Lenski experiment the so-called beneficial mutations, even though a lot of them were functionally compromising to organisms, specifically the bacteria, they're actually dying. They're losing them. Okay, so no, these have to come about apparently and then become stuck in place in every individual within the population. This has not been demonstrated. This is a lot of story. And so that's every point. I yield.
Okay, so really quick, fixation is not philosophical, it's mathematical, literally population genetics. We can demonstrate this using math. But the main thing I want to say, and then Mark can jump in and I'm going to be gone. But I just really want to read from this same exact paper, right? Because you've shown this paper multiple times tonight. You said this is a paper that does not explain any of these co-option processes, any of these evolutionary processes. You made that statement about this paper, and I'm very confident that you have not read this paper beyond the abstract, because the only thing that you quoted is the abstract, and it was very difficult to find this full paper. I looked all over, but I did find it. And later on in that first paragraph, it gives 3 different examples of ERVs being co-opted by the host organisms. The last example I want to show you is Zhang et al. Have identified an additional activity of co-opted ERVs, the alteration of the genome's 3D structure itself that may have the capacity to substantially affect gene regulation. So there is a study by Zhang et al. Showing explicitly the co-option of ERV activity for the host genome. Exactly what you've been asking for years.
Praise, do I get to respond to Grayson before Mark Reid goes? Because he said he's leaving.
Yeah, go ahead.
Yeah, go for
So
it.
I love how Grayson talks about fixation. Yeah, fixation is mathematical, and the philosophy comes into play when we're talking about all of these beneficial ERV sequences. Okay, firstly, the exogenous retroviruses have to, in fact, they have to become endogenized in the first place. Not only that, they have to overcome the built-in protectors and antiviral destroyers, you could say. And then the harmful components of these exogenous retroviruses that are now endogenized need to be destroyed through mutations. And then those functions have to come about. And then all of those ERVs also have to be fixed in place. Yeah, exactly. It's mathematical, and the mathematics don't work in terms of that many beneficial mutations coming about and those kinds of ERVs in light of the built-in mechanisms that destroy them to also be fixed in every single individual. Yeah, it's mathematical, and the math refutes this ridiculous idea. And so again,
I am absolutely certain that you have not done the math.
Yeah, I'd back that up. Have you done the math, Donny?
It's funny because the technical article that's coming out soon that I've authored with Christopher Roop, who's studied population genetics and fixation rates in great detail, it actually does address what we're talking about here in terms of the ineffectiveness of fixation rates. Okay, so Grayson butted in there because I know he can't resist himself. And so the other thing, again, he's just proving my point. No, that paper, other than just claiming co-option, other than just claiming, well, maybe this is how, you know, these functions came about and how they're functional in genomic organization and architecture. No, we have not observed this happen where, again, an exogenous retrovirus infects, it becomes endogenous, the harmful components of it are destroyed through mutations, and then it gains this kind of functional role in maintaining 3D chromosomal structure.
I just cited you exactly that.
What you cited did not show us in a lab, in the environment, anywhere where this happened.
Zhang et al. You have not read Zhang et al., but that is the study that shows exactly what you just said.
Read that last portion again, where it said maybe.
Okay, Zhang et al. Have identified an additional activity of co-opted ERVs, the alteration of the genome's 3D structure itself that may have the capacity to substantially affect gene regulation.
That's not saying that this novel functional role was observed to have not existed, and now it exists because of the rearrangement of chromosomes or mutations or whatever. You don't understand what you're reading, Grayson, because you don't understand the basics.
Donny, are you just denying the conclusions of the paper again?
No, you're misunderstanding the conclusions of the paper.
Okay, well, what I just read out loud, which was the conclusions, was written in the Journal of 3D Genomics by geneticists.
So I don't think that they're misunderstanding their own conclusions.
They are not
And I want
showing
to-
the co-option taking place.
Yeah,
They're
Zhang
not
et
showing.
al. Showed it. That's why
No.
it's a cited source in the paper that you yourself brought up and said explicitly does not make these claims.
The paper cited in it does not show an endogenous retrovirus, a
Have you read
pre-existing
Zhang et al.?
endogenous retrovirus.
Have you read it? I don't think you have.
I've read a great multitude of papers in the writing of my book, Endogenous.
Okay, but you didn't read
Retrovirus
Zhang
Handbook.
et al.
It's probably one of the ones I've read. I don't know it off my heart right now. But let me say this. I'll go on record saying that it definitely doesn't show a pre-existing endogenous retrovirus that doesn't have this function evolve this function.
Well,
I'll go on record
yeah,
saying
well, that's exactly
that-
what it shows. Because, let me explain here, because the endogenous retrovirus does not have a large-scale genome with a three-dimensional folding structure that has gene regulation environments. But what they've showed is that upon infection with this ERV, the actual three-dimensional structure is changed, which changes gene regulation. That's a co-option of function that the original virus didn't even have.
the 3D structure alters for the benefit of the organism through the function of these endogenous retroviruses. It's not showing how they evolved this ability to carry out that function. Maybe
Okay,
there's
so I'll read you the
conjecture,
conclusion of
storytelling.
Zhang et al. Okay. Overall, our results provide direct evidence for retrotransposons in actively shaping cell type and species-specific chromatin architecture.
Right. You don't understand what you're talking about, Grayson. You've probably only slept 5 hours in the last week. They are documenting the functional role in these endogenous retroviruses in shaping cell structure. They're not showing the evolution of cell structure shaping in an endogenous retrovirus that did not have prior to that functional role. That is not what they're showing.
Okay,
Grayson.
I'm reading from
And
the
if they
paper
are, I
again.
want you to make a video.
Again,
on
I'll
it.
just
Give me
read
the
from the
name of
paper.
the paper,
De
please.
novo
Can you give me-
insertion of ERV elements introduce new TAD boundaries, which is what we're talking about. They're in their lab. They're doing de novo insertion of ERVs and seeing how that affects the function. And they showed that by injecting a de novo, that means it wasn't previously there. It's a new source of ERVs. They showed that new functionality was imparted. This is exactly what you're asking for.
It's not a new
I'm
function.
giving you
If
exactly
you're-
what you're asking for.
It's
and you're
not
just
a new
saying it doesn't
function.
exist without reading it.
If you have a
You do sound like
if
you're
you have
hand waving it away, Donny.
if you have an endogenous retrovirus, we know endogenous retroviruses, some classes of them function in shaping cell structure. And you take an endogenous retrovirus pre-existing that has that function and apparently insert it into the genome of whatever organism it is, and then it carries out that function that it was already able to do. That's not witnessing the evolution of that function. How did that
I'm sorry,
function
Donny.
come
There's
about?
something in the background. Can Ron mute or something if he's?
I'm
gonna-
really sorry
yeah,
about
thank
that. I thought you couldn't
What
hear
the hell
clacking
was
keyboard.
that noise? I thought it was on my end.
Somebody
I don't
was
know.
being murdered. I'm just kidding.
Sorry, go ahead, Donny. I do apologize. It just was
No,
driving me crazy.
I would challenge Grayson, and if that is the case, which I highly doubt it is, but apparently over the last 3 years, you just finally answered the question, which I highly doubt. Go make a video, write up a commentary article on it, and let's see that, and then you can pass it around your evolutionary community, and even the Dr. Dans of the world can now point that out.
Why
But it
don't
really does sound
instead of
like you're
that-
misunderstanding what it's saying.
Instead of all
Just
that,
before
why
you
don't
come back, I would
you
like
just
the name
read
of the
paper?
Grayson. Give me the name of the paper.
Yeah. Okay. It is transcriptionally active HERVH transposons demarcate topologically associating domains in human pluripotent stem cells. So I'll just copy that into the side chat here, but it's by Zhang et al. From 2019. It's the exact paper that Donnie's always been asking for. He's finally gotten it, and
Thank
now
you.
he has to pretend it doesn't
Thank you, I
exist
appreciate it.
instead of just reading it. Maybe just read the paper first before you make conclusions about it, Donnie.
Okay, well, we've been at this for a couple hours and I'm getting kind of tired. So
can I just finish up then? I don't mind, Donny. I just want to finish up.
Sure, go
I
ahead.
feel like, design diversity. I get that you keep saying that, but you've got no evidence of it. That's the problem. You sort of keep making these assertions and that's all that they are. And you sort of say, hey, evolution is just a philosophy. Well, you're just working on your theology. It's even worse. And it's not philosophy. This is mainstream science we are talking about. And you sort of, I mean, I don't mean to be harsh. You sound like a flat earther saying, hey, you're not doing real science. We've got the real science. It's preposterous. That all of these academic institutions that you're drawing upon for your research, you are drawing upon these people's work for your research and then saying, well, I'm going to cherry pick what I want, ignore their conclusions, ignore how they've come to their conclusions, and then say that they're just engaged in philosophy is quite frankly really insulting to them. These are people that work hard on science and they're not making it up. They're not part of a philosophy. They're not part of a religion. They're just doing science. That's all. So the whole idea that people, evolutionary biologists are doing a philosophy and somehow you're doing science, when in actual fact they're doing science and you're doing religion, you're doing theology, because all of these assumptions that you make, that it's all being designed, that all of this doesn't work, that the conclusions that you drop from these papers are all driven by your one belief that a God has to have designed this, even though you've got zero evidence for it. And I'm sorry, but I'm not going to be sit here and lectured about how I'm participating in evolutionary philosophy when that is obviously what you're doing. So yeah, that's all I wanted to say. And I did want to know, are you putting your paper up that you're coming out with, Donny, for peer review or not?
My technical article, is currently in peer review. That's why it's taking a while to come out. Okay, so I want to address all that then, because Mark had stop. Mark had the last word the last time we did this discussion. I know evolutionists love to have the last word.
Yeah, no worries,
responding, okay? Now, Mark, I don't mean to be offensive, but you do sound a lot like one of them flat earthers in your attempt to tell us that we're all related to strawberries. That's insulting to say. That's science. That's insulting to me and a lot of people. You also sound like a flat earther when you argue for the co-option of these incredible functional roles in determining cell types, gene expression, embryological development, acting as antiviral protectors, just because an author with evolutionary bias claimed and asserted without evidence that co-option took place millions of years ago. That's insulting. That hurts. And I'm sorry, Mark, I'm not going to sit here and listen to you and be lectured on how these functional roles can come about just because you asserted it or some other evolutionists asserted it, okay? ERVs are turning out to be amazingly designed elements of DNA function. And you just hand wave the evidence for design diversity, when in fact there's paper after paper documenting the fact that all types of these DNA units, including pseudogenes, the genome in general, and we could have an entire debate on ENCODE based on the errors Grayson made earlier. Grayson and I debated this in our second debate for a while, where the evidence for genome-wide activity is astounding. 60 to 80% of the genome has evidence for activity. And within that genome is what? Pseudogenes, endogenous retroviruses, other classes of retrotransposons, allele sequences, all comprising amazing functional roles. And that is a direct prediction of design diversity, because guess what? And here's the last thing I'll say. It's the evolutionary community that predicts genomes of junk, non-functional leftovers, genomic fossils. But guess what? That's not what we're seeing. And that's why we as creationists and intelligent design advocates can put on paper these kinds of predictions associated with DNA function when you guys would hesitate to do so. And I yield.
Yeah, you realize that the guy that invented the term junk DNA, in the paper where he invented the term, he acknowledges that there are non-coding functional DNA.
Not as much as we find.
He doesn't make a quantified amount. He just says it exists. So the whole thing
he said most of the genome would reflect non-functional evolutionary leftovers, and that some function may be associated with the non-coding regions.
And that's
Some.
exactly what we see.
No,
0.1%
60
functional.
to 80% of the genome.
0.1% functional.
And
among all
transcription
ERVs.
is an energy intensive and resource intensive process. And it is pseudoscience. It is evolutionary philosophy to say that this is all noise. This is all spurious. That is not the case.
All right. Well, that is what all the geneticists and scientists are saying. So, Mark, I'll let you finish up
The
there.
geneticists and scientists,
No,
as
I
we've
want
seen
Donny
tonight,
to have the last word. He was right. I had the last word last time we had a discussion, so I think that that's only fair. But I will look forward to your paper. If it comes out, I will certainly read it, Donny. I guarantee you, if it comes out, I'll read it, definitely.
well, I appreciate that, Mark. And I do want to specify it's a technical article, not a paper. I don't want people making a video saying,
Oh, okay, gotcha.
SFP
Yeah, I'm
lied.
sorry.
The paper's coming out.
Yeah, it's
Okay.
not being
Okay,
peer
okay.
reviewed either.
It's being reviewed by people with PhDs in genetics. So
Who's
Grayson,
reviewing
you
it?
got to get some sleep, man. You got to get
He's
some sleep.
talking
But I
about
will say,
Stanford,
I
he's
no,
talking
I
about
just want to say
Google.
outside of the conversation, because it's over, I don't want to bring up any new points to the
Okay.
audience. Although these discussions at times may appear passionate, people like me, Mark, Grayson, hopefully would agree with this. These topics are important. We enjoy engaging them. And so although they may appear passionate at times, there is, at least for me, there's no animosity. I always, especially Mark, I appreciate his time that he always gives for these debates. And I find him a lot of fun. I find him a lot of fun to engage because, Mark, you're one of the few that I feel I got to match up to your rhetoric. You know, I got to match your rhetoric with better rhetoric.
I don't think
And
it's
so
that good.